All right, in this video, I'm going to introduce you to polar coordinates. And you may be thinking to yourself, why do we need another coordinate system? We already have the XY coordinate plane. Why do we need another one? Well, it turns out that some complex algebraic equations can be represented more simply in polar form. And sometimes there are complex polar equations that can be represented more simply in the XY world. So having a different coordinate system helps us to simplify our lives sometimes. Sometimes our lives can be simplified by using polar coordinates, and sometimes our lives can be simplified using XY coordinates. Polar coordinates also provide a better means of location when we are in the air or at sea. So in navigation applications, it's best to use polar coordinates. Polar coordinates also allow for multiple representations of the same point in space, whereas rectangular coordinates do not. So if I'm given a point in the XY coordinate system, that point only has one specific address. It has an X coordinate and a Y coordinate, and those X coordinates and Y coordinates cannot change, because if they do, they will describe another point, a different point in the XY plane. But if you give me a point in the polar coordinate system, I can rename that point using actually infinitely many different names, and it would still be in the same location on the graph. And the fact that we can give multiple representations of the same point makes the polar coordinate system more flexible than the XY coordinate system. And then last but not least, the polar coordinate system is very useful for modeling problems involving circular motion and radial forces when we study engineering, and magnetic or gravitational forces when we study physics. So now let's talk a little bit about what this polar coordinate system looks like, and maybe find out how it is similar to the XY plane that we're used to working in. So a polar coordinate system is made up of a fixed point O, and we'll call that point O the origin, or the pole, and a ray called the polar axis. So we have our origin or pole, and we have our polar axis. Each point in the polar coordinate system is defined by an ordered pair r, theta, where r is just the distance from the pole to point P, and theta is a directed angle from the polar axis to point P. So what does that mean in English? It means that I can give you any point on the polar plane if you give me an angle and a distance from the origin or from the pole. So for example, if I wanted to find the point 2, pi over 4, I would create an angle from the polar axis of pi over 4. And the point P would be 2 units away from the origin along that pi over 4 angle. So there's our point P. What if we wanted to plot the point P, which is 0, pi over 2? Anytime the r, or the distance from the pole, is equal to 0, then the point P, no matter what the angle is, will always be located at the pole. So point P would be at the pole in this case because our r is equal to 0. Let's look at one more example. What if we wanted to label the point P, which is -1, pi over 4? We would begin by creating an angle from the polar axis of positive pi over 4 units. But in this case, we notice that our r is negative. If r is negative, then the point lies opposite theta. So in this case, our point P would lie 1 unit away from the origin on the angle opposite pi over 4. So in this case, our point P would be here. So at this point, you may be thinking to yourself, well, if we're plotting points in a different way, might it be helpful to have a different type of graph paper on hand? And the answer to that is absolutely. So a rectangular grid is helpful for plotting points in rectangular coordinates. But to plot points in polar coordinates, we'll have to use some graph paper that looks like this. Notice that this grid consists of circles centered at the pole here and rays emanating from the pole. So this graph paper actually is good because it tells us here's a distance of 1, 2, 3 away from the pole, or if I go this direction, 1 unit away, 2 units away, 3 units away. So the concentric circles give us a good way of knowing how far away from the pole we're going to be. And each one of the rays emanating from the pole tell us our angles. So that would be a pi over 4. This would be a pi over 3. This is a pi over 2 angle from the pole. So this new type of graph paper is good for us because it gives us all the angles that we're going to need as well as the distances from the poles. Now you might notice some similarities between these two different grids. In the polar coordinate system, the pole is just the point 0, 0 in the rectangular coordinate system. The polar axis in the polar coordinate system here is just the positive x-axis in the rectangular coordinate system. All right, so hopefully that gives you a pretty good idea of what this new polar coordinate system is going to look like and how to plot points in the polar coordinate system. In the next videos, we're going to actually get into graphing points in the polar plane.